Hello my dear students, welcome back to Learn Physics. In today's topic, we are going to discuss about electrostatics portion. Today also we are doing 1 mark questions only from the topic electric field. This is the part 2 series, that 1 mark question series part 2. I created a new playlist for this 1 mark questions series, that is, this one is part 2. First we will go through the theory portions once more. Electric field. What is meant by electric field? Electric field due to a given charge as the field that penetrates the space around the charge, in which electrostatic force of attraction or repulsion due to the charge can be experienced by any other charge. That means if one charge is there, effect of that charge around its region in which another charge can be attracted or repelled. Attracted or repulsion can happen to that charge. That is called, that field is called, or region around the given charge is called an electric field. Next is electric field intensity. The electric field intensity at any point is the strength of electric field at that point. It is defined as the force experienced by unit positive charge placed at that point. So electric field intensity is the strength of electric field. How much strong the electric field is, that one is represented with the electric field intensity. So how we will calculate this electric field intensity? It is force acting per unit positive charge or unit charge, that is called electric field intensity. So we can represent electric field intensity as E equals F by Q0. Electric field intensity and F both are vector quantities. Electric field intensity due to a point charge is E equals 1 by 4 pi epsilon 0 Q by R square into R0. That R0 is the unit vector. Okay, so this formula is very important to find out the electric field intensity due to a point charge. That is E equals 1 by 4 pi epsilon 0 Q by R square. The direction of force depends on the sign of source charge. That means, see, whether the source is positive, whether we are giving a positive charge or negative charge, depending on that, the direction of force will be changing. So if it is a positive charge, what will be the direction of force? If it is a positive charge, direction of force will be same as that of the direction of electric field. Due to that positive charge, what will be the direction of this electric field? The same way, the direction of force also will be in the same direction. If the source charge is negative, opposite to the direction of electric field. Next is, we are going to discuss about electric field lines. It is a straight or curved path in an electric field such that the tangent to it at any point gives the direction of electric field intensity at that point. That means it's a electric field lines can be a straight one or curved one. But if we are drawing a tangent to that field lines, which will be giving the direction of electric field intensity at that point. And some of the properties of electric field lines are given here. Electric field lines are continuous curves. No two electric field lines of force can intersect each other. Why is it so? If it is intersecting, the tangent to that intersection point will be having two directions. So it's not possible. That's why no two electric field lines of force can intersect each other. Next is electric field lines are always normal to the surface of conductor. What will be the direction of electric field lines? It will be always perpendicular to the surface of the conductor. And next one is magnitude of field. What will be the value of magnetic field? Electric field is represented by the density of field lines. If the number of field lines are more, then we can say electric field intensity also is more over there. Okay, if the field lines are less, so electric field intensity also will be less. Here in this first property, we told electric field lines are continuous curves, right? But they are not closed one. That one you should remember, because it will be starting from the positive charge and ends at negative charge. Okay, it's not a closed curve. Clear? Now we are starting the questions. First question, figure shows the electric field lines for 2-point charges separated by a distance. What are the signs of Q1 and Q2? Determine the ratio of Q1 and Q2, or ratio of Q1 and Q2. That is, we should find out Q1 by Q2. Figure shows the electric field lines of 2-point charges separated by a distance. So Q1 is here, Q2 is here. What are the signs of Q1 and Q2? We know from positive charge, electric field lines will move out, and Q2 is towards negative charge. For the negative charges, electric field lines will be ending. Electric field lines will be ending at negative charge and will be emanating from the positive charge. Now you tell me which is positive, which is negative. Q1 is positive and Q2 is negative. Next is determine the ratio of Q1 and Q2, or Q1 by Q2 you should find out. Density of field lines we should calculate for both the things. See, for Q2, 1, 2, 3, 4, 5, 6, 7, 8 are there. And for Q1, these 8 are there. Along with that, 9, 10, 11, 12, 13, 14, 15, 16 are there. So what will be the ratio? 16 divided by 8, that is equal to 2. Right. So here next answer is Q1 has positive charge and Q2 has negative charge. As the number of field lines leaving Q1 is twice the number of field lines terminating on Q2. Therefore, Q1 by Q2 equals 2. Next question. Two protons A and B are placed in between the plates of a parallel plate capacitor charged to a potential difference V as shown in figure. The forces on the two protons are identical. Is the statement true? Give reason. Okay, tell me, see here A and B, in these two positions, two protons are kept, and it is placed between the parallel plate capacitor. The charged to a potential difference V. So potential differences are there between the plates. So here the direction is showing the electric field. Which kind of electric field it is? It's a uniform electric field, because it's parallel lines. So it is uniform electric field. We should find out the forces on the two protons, whether they are identical or not. See, force F is equal to Q into E. Right. So forces depending on charge and electric field. Here we know electric field is uniform. But what about the charge? Since both are protons, the charge also will be same. So whether it will be identical? Yes, it will be identical, because field between two parallel plates is uniform. Charge of proton is also same. F is equal to QE. Next question. A proton is placed in a uniform electric field directed along the positive axis. In which direction will it tend to move? Proton is placed. Proton is having positive charge. Right? It's moving along the positive axis. So the direction of electric field is along the positive axis. Proton is having positive charge. So proton will be moving in which direction? If the source charge is positive, force will be acting along the direction of electric field. So since proton is positive, electric force will be acting in the direction of positive axis only. Right? If it is an electron, what will happen? It will be moving opposite to the direction of electric field. So in the negative axis it will be moving. So here the answer is, as proton is positively charged, it will tend to move along the positive direction, that is along the direction of electric field. Next one, figure shows the electric field lines around 3-point charges A, B, C. Which charges are positive? Which charges has the largest magnitude? In which region could be electric field is 0? So here we will see one by one which charges are positive. So here from A charges are moving out, so it is positive. From C it is moving out, so that also positive. From B towards B, all the charges are moving towards B, right? So it is negative. A and C are positive, B is negative. Now, which charges has the largest magnitude? Which is having the largest magnitude? Here, see, number of field lines will be representing the magnitude. For A, 1, 2, 3, 4, 5, 6, 7. Right. For C, 1, 2, 3, 4, 5, 6, 7, 8, 9. Along with that, towards B also it is moving. So C is having more magnitude. In which region could be electric field as 0? Electric field will be 0 between the like charges. Since A is positive and B is negative, between A and B it is not possible. Since B is negative and C is positive, between B and C also, electric field 0 region is not possible. So electric field 0 region is possible only between A and C. So in between A and C, to be more specific, to near to which one it will be, A has less density of electric field lines and C has more density of electric field lines. So electric field 0 region will be very much closer to A compared to C. So the answer you can write down as charges A and C are positive. C has largest magnitude. Thus, the electric field 0 region will be between A and C, as magnitude of A is smaller than C. Neutral point will be lying closer to A. Clear, children? So I am winding up for today, and next day I will be coming with the topic electric dipole. If you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.